האג'נדה, אבל תפתח. לא? Guys, if you can just grab your seats, we'd like to begin in a couple of minutes. Please grab your seats. We'd like to begin in a minute.
זה אומר שאני לא יכול לעשות עם העכבר במצגת.
אוקיי.
תעביר לה את זה, שאתה מתחיל פשוט, לחיצה אחת על העכבר כאן, ואז הקליקר יקבל את השליטה. הייתי לא יחבוד פה שהתחיל את ה... עכשיו מתקדים?
Сказал, что чтобы клик работал, надо нажать один раз экран. So, hi everyone. Thank you for coming here. It's really nice to see that with every event that we do, we have so much interest and a dedicated community that is coming to every one of our events. So I'm David, I'm from Toloka, and we are one of the organizers of this event. So together with Taboola, who are hosting us, so thank you very much, and Agoda. And the theme of the meetup today called Boosting Your Recommender Systems. So we're gonna have 3 great talks today. I'm gonna present the speakers and the agenda. Well, beforehand, I would like you to take a few moments and to join our data-driven activities. You can scan the QR code here, and it will direct you to the site so you can follow our activities. I'll give you 10 more seconds. What, do you get an error?
Just send a link to the
Okay, so we'll fix that. We'll send the link afterwards. I hope the next one will work. So Dana, can you just press the screen? I think it's good. Yeah, so another QR code for the meetup group. So you can follow our events. We're gonna do a lot more. I hope this one works. If it doesn't, just tell me. Works? Yeah. Perfect. No. No? What? Maybe just it's your phone? Doesn't work? Works. Somebody said works. Okay, so just to not get again, you can, we will send you later the links. You can join our meetup group. We're gonna do a lot more events such as this one. So let me just quickly go through the agenda. Dana, doesn't work. Can you press? Okay, sorry. Yeah, so we're gonna open up with a talk from Taboola, Sigal Gutman. She's the algorithms team lead, and she's gonna talk about how to improve your recommendation systems using metrics such as CVR and CTR model. Afterwards, we're gonna have Agoda. Yair is the data science manager. He's gonna talk about how to grow small segment with big recommendation systems. I'm sure you're all familiar with Agoda. And the third, it's going to be a talk from Toloka, so our company, and how data labeling and human labeling is helping recommendation systems and improving them. And then we're going to have a Q&A session. We're going to have a short break between them, and then we're going to have a Q&A session with the speakers. So with that being said, again, I want to thank all of you for joining, and I want to invite our first speaker, Sigal. Yeah.
So hi, I'm Sigal. I'm an algorithm team lead at Taboola. And today we are going to talk about how we optimize CVR with a CTR model. And if you are not familiar with this notion of CVR and CTR, don't worry, I'm going to explain them later. And if it's still not understood, so feel free to ask. Is it working? Yes. So the agenda for my talk is, first of all, Taboola. I'm sure all of you are familiar with Taboola, but I'm still going to explain who we are and what we do. And then we're going to talk about the problem of accidental clicks and the solution we found to it. Okay, so Taboola, we are the leading content recommendation company in the world. We sit in the biggest publisher sites like Ynet in Israel or Bloomberg outside Israel. And what we do is when you read an article, after you finish it and you think what else you want to read, what you are going to be interested in now, we recommend you about the next item you want to read or to know. For example, if you read an article about what you are going to do in the upcoming holidays, and after you finish, we put an item about the nine best places to ski around the world. Okay. Okay, so we have a huge scale. We have 1.4 billion unique users per month. We have over 3 billion page views per day and over 500,000 HTTP requests per second. And the problem that we are trying to solve is how to match millions of content items with over a billion people every month. We want to give every user in every specific context the item that will be most interesting for him. And we want to do it by making both publisher and advertisers happy. So the publisher is the one that the user is reading the article, and we put our recommendation into it, like Ynet and Bloomberg. And what the publisher wants is to have as much revenue as possible. So when you read Ynet, for example, you don't want to pay money to read Ynet. And we are a big source of revenue for the publishers, so they can create good content for you. And the publisher also want their users to see items that makes them feel comfortable and safe and that will fit their brand. So this is what the publisher wants. The user wants to see items that are interesting to him, that he's engaged with, and he wants to feel that we keep his privacy. And of course, he wants to feel safe and not to see something that make him feel uncomfortable. Now, the advertisers are very important because they're the ones that actually pay the money and for all of this to work. They are the ones that creating the content items that you see in the bottom of the article. And our business model is that they pay us money. If you click on the item, if the user click on the item, they give us money that we shared with the publisher. And if there is no click, they don't pay anything. We have a large diversity of different advertisers. For example, we have Toyota that want the user to purchase a car. And we have other advertisers that want other things. Like they want as much scale as possible, as much users to know them and to be in their site. Okay. So a little about the notions you're going to see in the following presentation. So we have the CTR, which is the click-through rate. This is the number of clicks we have per impression. So for example, if an item was recommended 100 times and it got 1 click, the CTR is 1%. The CPC is the cost per click. This is how much money the advertiser is willing to pay per click. The conversion or the action, this is a tricky part. This is what the advertiser wants. And there is as I said, there is large diversity of different advertisers, and there is large diversity of different conversions. So the advertiser is the one that's defining what action he wants. For example, one advertiser can decide that the action he wants is the user gets to the bottom of the page, and another one decides that the action he wants is the user to leave his email. The CVR is the conversion rate, is how many conversions the advertiser got per click. And the CPA is cost per action. This is what really the advertiser want to optimize. And this is how much money he paid to get the number of action. So for example, if we recommended an item 10,000 times, and this item got 100 clicks. So what is the CTR? 1%. And this item got 1 conversion. So what is the CVR? 1%. And if the advertiser is willing to pay $1 per click, so what is the cost per action? What is the CPA? $100, exactly, $100 per action. So now is the question, is 100 CPA is a lot or is it little? So it depending on the advertiser. If the advertiser just wants as much users to know his site and to visit his site, probably $100 per user is a lot. But if the advertiser wants to sell a car and every action is users that left his mail or his phone number and interested to hear about his product, so probably $100 is a great CPA. Okay, now we can continue. Sorry. So this is the core of Taboola. This is where the magic happens. We have millions of possible recommendations. And we have a user, a specific user We know many things about him. We know what he's interested in. We know what is he reading right now. We know where is he from. We know the hour of day and day of week. And we want to give him the best item. Now, best is a tricky question because we have different stakeholders that we want to make happy. We want to make the user happy, we want to make the publisher happy, and we want to make the advertiser happy. And sometimes they want different things. Okay, so we have this ranking function. This is like the happiness function who wants to make everybody most happy. And we give this function 3 variables. One of them is the CPC, the cost per click. And of course, that if the advertiser is willing to pay more per click, he will be more competitive and he will get a higher score. The other one is the estimated CTR. This is the prediction of what is the chance that the user in this specific context will click on this item. So we have a very cool deep learning model that we give him all these signals that I was talking about before. And the output of this model is the prediction of the predicted CTR for this user to this item. And the last one is the CVR, the predicted CVR, because we want the advertiser to be happy too. And this is also a very cool deep learning model, which is predicting the chance to get a conversion if the user had clicked. So what we do, we take our recommendations, we give each one of them a score, and then we rank them, and we give the user the items that has the highest chance to make everybody happy. Are there any questions so far? Okay. So, that was a little bit. Okay, so I was talking about it before, but let's go a little deeper into it. So let's say that the user has saw an item and he was interested in it and clicked on it. And he got to the website of the advertisers. In the website, there are many things the advertiser might want the user to do. Maybe you want the user to purchase something. Maybe you want the user to sign up and to get newsletter. Maybe you want the user to leave his mail or his phone number. Maybe you want him to add to cart some product. And maybe just want him to explore as much as possible in his website. All those things can make the advertiser happy, but sometimes there are less happy cases where the user got to the advertiser website and he says, what, I didn't want to be here. And he bounced back, he closed the website. And we define those clicks as accidental clicks because the user didn't want to arrive to this place. And we say that if the user was less than 4 seconds on the advertiser page, so this click was accidental. There can be many reasons for why the click, why accidental click would happen. For example, if you scroll your mobile and the site is loading slowly and you're trying to go down and then you click on something you didn't even saw and didn't want to click on it, and you go to another page you didn't want to be here. And these accidental clicks raise a question of what are we going to do with them? Like, on one hand, they really happened. There was a click, the advertiser paid for it, and this click will happen in the future too. On the other hand, the user wasn't interested in this item. So there is a question, is there any affinity between the user and this item? Can we generalize from this data? Do we want to optimize the 2 clicks that the user wasn't happy with? So these clicks are problematic. So what we wanted to do is to try and not to learn from them and to remove them from the data set of our CTR model. Okay, was that clear? Yes. So great question. So I would say about 4% of clicks. Yes.
The definition of the bounds time, only 4 seconds, or is that something else?
So you can, the definition of bounds is 4 seconds, but there are other ways to define accidental clicks we might want to introduce in the future.
One more question. Why 4 seconds?
So it's a great question. In the industry, you can find a different metric between 3 and 5. And we did an analysis to show a correlation between the chance to get a conversion and the time the user was on site, and 4 seconds is a good candidate. There was some, okay, yes. Oh, sure. Okay, thanks.
And why remove this bouncing example clicks from dataset? Why not count that as negative feedback?
Great question. It's a possible. Okay. So the question was why to remove the accidental clicks from the data set and not treat them as negative examples because they were clicks. We can treat them as impressions without a click. So it's a possibility we might explore in the future, but because the percentage of the accidental clicks is low comparing to the negative example, it won't have a big effect, okay? Because we have little clicks and a lot of impressions without clicks, but it's a great question, yes.
Maybe just trying to think
Yeah, if you want to predict accidental clicks, so it might be a good way. But here we must have a binary to make it a binary decision: is the click accidental or not? But I totally agree. It's not a clear cut. We had to choose some threshold. Okay. Yes.
So far, metrics and many methods, but didn't explain how we differentiate between different users. So you assume all users are the same, or you have
no.
How do you collaborate?
We collect user history metrics, so we know what the user was interested in the past, like what he was engaged with. Okay. Is it?
But you work with other kids, or for example, like the Facebook account, or just like
no, we don't have the Facebook account, only our data. Okay, I will continue. So on the one hand, it makes sense to remove them and not predict them because these clicks are not good for the advertiser and are not good for the user. On the other hand, this click will happen in the future. So our prediction might be biased because we won't see them. The model is blind to them. So this is a small problem, just 1 minute. But the biggest problem is that we have this data only for part of our advertisers. The definition of a click as accidental is relying on a post-click information. And some of our advertisers share this data with us and some don't. So if we remove those clicks from the data set, we can remove them only for part of our advertiser. And for part of our advertiser, we can't remove them. What will happen when we go to our happiness function that is trying to give a score per item and to rank them between which item is the best? The items of advertisers that share this data with us will predict CTR only for real clicks.
What do you need advertisers? You have the data of clicking and again, how long you stay in the...
I want to rank items in order to give each user in each context the best item. Because it's something from his website. Yes. Okay, so when I give the CTR prediction, I will give CTR prediction based only on real clicks for some of the advertiser, and CTR estimation based on all clicks that is trying to predict CTR for accidental clicks as well for the other part of advertiser. And when I do the comparison, the advertiser that give us this information will be less competitive. And this is an undesired effect. You had a question I wanted to ask? Mm-hmm.
How do you say that when you pay for clicks, you need to pay for clicks, like, how could it be? Who takes that?
Okay, so the question was if we pay publisher for those clicks and who takes the money. So it's a great question. Today, for accidental clicks, advertiser pay money. And we share this money with, the publisher gets money for those clicks. So when we remove them, we just remove them from our models because we don't want the advertiser to pay money for clicks that he get no value from. Okay, but if it will happen in the future, he will pay for it. Okay, so as we said, there are promises to removing those clicks because they are bad for the advertiser. On the other hand, there is a risk because they make a skewed data set and might make the advertiser less competitive. However, in Taboola, okay, we have a great tradition of A/B testing. We have huge scale, we have huge data, and when we want to check something, we go online, we open a variant of default of the regular model and another variant of a model that was learned data without accidental clicks. Now I have a question to you. What do you think will happen? What will be the result when we compare these two variants? What? Better to the leads? To the conversions, you mean? Yeah, better to the conversion. Okay. Another ideas? Okay, so let's see. So the result you see here are the result of the test of removing accidental clicks for the advertisers that share this data with us. And the number you see here are only for those advertisers. Okay, so as you said, it does improve CVR and CPA. They get more conversion for the same number of clicks, and they pay less money for it, which is great. Like 8% improvement in CPA is huge. However, because they are less competitive, it kills scale. They are less competitive compared to other advertisers. So we recommend them less. They get less clicks, and the biggest problem is that they get less actions. So if an advertiser pay less for each action, but he got 40% less actions, it will not be not good. This is bad. So we had to fix that. We saw there is a potential, but it's not enough. So we understood that what we have to do, because we don't have this data for the other part of the advertiser, we must keep the ratio of clicks to non-clicks as it was before the removal of the accidental clicks, in order for the competition to be fair and the prediction not to be biased. Okay, so what we did, for every accidental clicks that we removed from the dataset, we duplicated another click. which wasn't accidental, where the user was engaged with the site. And in this way, the model didn't see the accidental clicks, but he saw the same ratio of clicks to non-clicks as before the removal. Okay, and what happened now? Okay, so we improved CVR and improved CVA, and we didn't kill scale. We still had the same number of impressions and even increased action by 17%, which is a great result. Yeah. To the baseline. Yeah. So, summary, we have a problem of accidental clicks. And in order to solve it, we remove those accidental clicks from the dataset of the CTR model. However, because we have partial data about the accidental clicks that we get only from a part of our advertisers, it creates a skewed dataset which kill the scale for the advertisers that share this data with us. In order to solve it, we duplicated real clicks that the user was engaged with for every accidental clicks that we remove. And in this way, we improve the advertisers' metrics like CVR and CPA without hurting its scale. And yes. Question. Offline or online? Offline, we use the loss and the rock. Yes.
The data to real clicks. Did the opposite, it was skewed to the negative by removing it to skewed it, but adding another click that maybe got later on actions.
Yeah.
So it's positive and you want it to click, change the data. So when you don't really want to
you are right that by duplicating a different row, it might create bias to different signals or features of the model. However, it solved the biggest problem of the competition between different advertisers. It was the biggest issue. Okay? And yes. I forget.
The clicks, you see their increase in action 70%, right?
7%. In scale.
In scale.
The advertiser got 17%.
So, first of all, it's great, but how can you explain? Like, it's a great increase.
Because he was recommended in places where users were more engaged with. Okay, so if, for example, he had the same budget as before, he used this budget only in more relevant places, and he got more actions.
And this 17% is it for advertisers that shared with you or not?
Only for the advertisers that shared it with us.
Okay.
Yeah, the other one didn't benefit from it, but didn't get hurt as well.
Okay.
I have a couple of questions from the online chat. We also have people online, so I'm gonna read them in the order, okay? So can the accidental click be treated as a false recommendation, like another class instead of deleting it?
Like a negative example.
Yes.
Yes, so there was this question before. It's a possibility, but we believe that the effect of it will be low because we have a lot of negative examples and much less positive examples. So, but yes, it's true. It is possible.
And another question, how do you avoid the client stealing problem? And then an explanation, your advertiser is AliExpress and you're providing recommendations for Amazon website. Your CTR and CVR will be great, but your client is losing revenue. So how do you avoid this client stealing problem?
I didn't understand the question.
Okay. So the question is, how do you avoid? And then quote, the client stealing problem. And then a further explanation is your advertiser is AliExpress and you're providing recommendations for Amazon website. And then your CTR and CVR will be great, but your client is losing revenue.
If the advertiser and the publisher are in competition, so the publisher might block specific advertisers that it doesn't want to be recommended on his site. Yes.
Can you use the thank you very much.
Okay, hear me now? Oh.
Yeah,
it's for okay. A question regarding the general approach that you described of predicting the CTR. Have you had a chance to tackle this problem as a recommendation problem, like user to item recommendation?
This is not something we do today. Like,
okay, thanks.
Yeah.
One more question.
So if I understood it right, when you replace accidental clicks with duplicated real positive clicks, don't you discriminate those advertisers who don't share accidental clicks with you because they don't get these duplicated clicks?
You mean, do we kill their scale?
Well, if an advertiser doesn't share accidental clicks with you,
Yeah.
you don't duplicate positive clicks for him. Doesn't it create the discrimination which you wanted to avoid in the first place?
No, because the ratio of clicks to non-clicks is exactly as before before the duplication. The ratio is the same. The advertisers that do share this data don't get more clicks. They get the same number, just real clicks.
Okay.
Okay. Thank you.
Thank you, Sigal, for a very interesting talk. And judging by the amount of questions, I think you will be able to also to catch Sigal on the break and ask her personally or to the mail. Great. So the next talk is going to be by Yair. So let me just quickly invite him.
Invite me.
Invite you. Yair, the stage is yours.
Thanks. It's great to be invited. Thanks to Toloka and Taboola. Hi, everyone. Nice to see some familiar faces, guys at home. But it's not my slides, so okay. So the title of my talk is how to promote a small segment within an existing big recommendation system. It's not the most compelling title for a talk, but it's quite descriptive. So a little, thank you. Where should I point it? Okay, so a little bit about me. I've been around in the industry for about 13 years, different domains. The last 2 years, I'm a data science manager at Agoda. I'm responsible for the small local site that we have here in Tel Aviv. This is my LinkedIn address. Feel free to connect and give feedback after the talk. I really like to hike in the desert, especially when I was young and fit. So you're right, Sigal, it's not working. The agenda for today. So it's not a very technical talk, but I think the use case is interesting. Having a small segment that we want to promote. So we first define the problem and then just describe like 2 or 3 things that we tried and what worked for us and what didn't. So a little bit about Agoda before we start. So it was founded in 2005. It's a big online travel agency. So it's part of the Booking Holdings group. Other companies in the group are Booking.com, Kayak, Priceline, Rental Cars, many other companies that maybe you didn't know that are affiliated. And Agoda's special focuses in Southeast Asia and Oceania. So these are the core markets of Agoda. The headquarters are in Bangkok. We are a group of about 42 data scientists, and here in Tel Aviv, we're about 9 and growing. And in travel tech, there is ML all over the place. When you surf the website, you get like, I don't know, dozens of models running in the background, making all kinds of decisions of what you see, the prices you see, the hotels you see, and so on. So this page is the search page. You're familiar with it either from Agoda. Has everyone used Agoda before as a user? Okay. Yeah, the booking group, definitely. So it looks rather similar, right? You input a destination, a date range, a few other specification, you have some filters, and you get a list of hotels. So this is powered by our recommendation engine, right? It tries to match, to show the most relevant hotels to the user. And we have a very optimized RNN model that runs and tries to take into account both the user context and the property, the hotel properties and the search queries and so on. And there are a lot of business rules on top, as sometimes recommendation engines have, and product people like to add on top of our beautiful machine learning models. I won't touch about this core engine. I'm gonna describe how we interact with it. It is optimized in an offline metric of relevancy, but it's tested on our business metric, which I'll describe in a moment. So this is the segment that we're trying to promote. It's called NHA, non-hotel accommodation. It's kind of an annoying name. For the first time I saw it, why is it non-hotel? Why does not call it like homes or apartments or something like that? The reason is that it's a huge spectrum. So you get all kinds of properties under NHA. So starting from bungalows on the beach, villas, minsu, which is, destination specific. This is a guest house in Korea or in Japan. And also serviced apartments. So serviced apartments are almost like hotels. Some of them, it's like a building of apartments that are cleaned every day. Sometimes you have reception, but it's not like an hotel. It's for longer stays and so on. So it's really a continuum of different type of properties. So this is why I surrendered my resistance and started using NHA. And why is it an interesting segment? So first, let's talk about the effect of COVID. So COVID was like a huge catastrophe, right? Once in a lifetime thing, especially for the tourist industry. So what you see on the left is it's the decline of demand of users booking in Europe. So it was like minus 90% of the business in 1 month in 2020. And what you see on the right is this is Agoda numbers. So you see the drop. This is for NHA properties, different types of NHA, multi-room, single room, and hotel-like. We divide them into these 3 categories. So you see the drop here, but what you see is the red line here that the relative part of homes and hotels actually grew. So it fell, but less than 90%. Okay, so the fall was not as drastic, and the recovery was faster for hotels and for apartments and homes. If you remember, people didn't want to be with other people; you prefer to book a small home in a remote place. So so this is like one thing that helped to boost the segment. And another thing is people started preferring longer and longer stays. Right, remote work became very popular. We all wanted to get away from quarantines that was closing in on us, and this is like the dream, right? Writing from your laptop in some kind of a tropical island. And in Airbnb, these are the share of properties that started taking like 2 weeks minimum stays, and the reason they did it is because people actually were willing to book for longer periods. So this definitely increased. And also, this is not related to COVID. People started looking for more special experiences that sometimes hotels could not provide. By the way, one of these pictures is fake. Who thinks the shoe picture is fake? Okay, who thinks the pumpkin picture is fake? Okay, not everyone vote, but you're right. The pumpkin house is fake. I created it a couple of days ago with a stable diffusion model, a pumpkin house in the forest, something like that. But it's not the same resolution. It's not a fair comparison. But yeah. Okay. So looking for unique experience is also very important. Let's talk a little bit about the challenges. So first, in Agoda, we have a shared feed. So unlike Airbnb, when you go to Airbnb, you usually your intent is clear. You want to book an apartment or a house, right? In Agoda, it's not so clear because we accommodate for different type of properties, both hotels and homes, and for a different mix of users with different intents. Some of them are looking for hotels, but might be open to change their mind if they see a good price for an apartment in the city. Maybe they switch for an apartment. So the mixed intent users makes it, and the mixed feed makes it more challenging. The other problem is that homes are long tail by definition, right? They don't get a lot of traffic like hotels. It's very sparse. You get like one booking a month, or for some properties even less. And our ranking model was optimized for many years for hotels with a lot of traffic, and it's a really painful long-term problem. Like, I guess there are analogies in many other business use cases from your domains. Another thing is that there is less content. People write less reviews. There are less pictures of the property, less data to work with. So that's for the long tail. And what makes things more difficult is that the cold start problem is even more evident. People could Google for, I don't know, Hilton Tel Aviv, but no one would look for Yair apartments. I did. There is a place in Jerusalem called Yair Apartments, but usually people don't search for these properties directly, right? So getting this first one or two first bookings is very difficult, and our ranking engine is really, looking forward to properties that, got their first boost. Someone who was interested, there was a transaction, and so on. So the cold start problem is very, very difficult for homes. And another thing is it's a different world. For example, when you book an hotel, usually the booking is instant. You get a confirmation to your email in a minute. In homes, it's not the same. Sometimes the owner would like to approve you, would like to see your rating or whatever. So it's not an instant transaction. So this is what we call book on request. Another different features, for example, superhost. So Airbnb has it, for example, if the owner is very responsive and polite and so on, then he gets this superhost badge, which is something that we don't have for hotels. So there's a lot of features or domain knowledge that is specific for homes that is not formulated for the general ranking engine, or even if it is formulated, the chance that it would pick this very sparse feature that is relevant for such a small part of the data is very small. So these are the challenges. I would just like to add a new term, the second one after NHA. This is how Agoda defines value. That's the definition of money in Agoda. It's called LTC, or lifetime contribution. Basically, there are three main components: the margin prediction, which is the revenue that you get. But it's important to note that even if someone makes a booking, it doesn't mean that the booking is going to happen, right? Most of bookings today are with free cancellation, and some of them do get canceled. So we have cancellation rate prediction models that tries to accommodate for that, and we try to take that into account. So, but this is the main part of the revenue. The second part is what we call DLTV. So LTV is lifetime value, right? What are the chances that if you visited the Agoda website, you will come back next year and make another booking? So this is, and the delta part of it is like how much we expect the lifetime value to change given the current booking, okay? So it might be useful even to lose in this current transaction if we believe that you will come back next year and be profitable for us, okay? So this is like the future contribution, another model-based component. And the VC part is what we call the variable cost. It's basically the overhead cost for customer support and so on and so forth. So this is the definition of value that we try to optimize. And let's define the problem. So now we want to optimize this LTC. We have a budget to spend. We want to maximize the NHA LTC, right? We want to get the value from homes, but we want to do it such that we still maintain some efficiency. So how we define efficiency? The boost in NHA LTC, the NHA lift, divided by the opportunity cost that we lose. Because if we take traffic from hotels and move it to homes, we are also losing money, right? So let's say in an ideal example, this ratio is 1-to-1. So for every dollar that we move from hotels, we get $1 in NHA. That's great. We can, be very flexible in our business. But usually we don't get this efficiency. So let's say if it's a efficiency of 1 to 10, we need to spend $10 to get $1 in NHA. It's also very poor, right? So I will talk about how we measure this stuff. But this is what we call efficiency. And the next part, now we've defined the problem. The next part would be to describe different approaches of how, given this framework, we try to tackle this problem. So the first approach was to create some kind of a personalization for NHA. We call it the intent model. Basically, what the intent model does, it tries to identify NHA-related users, or more precisely, sessions which have high chance of converting to homes rather than a hotel. So this is basically a classifier that tries to estimate that given the chance that there will be a booking, it will be an NHA booking, okay? So the likelihood of the user in this session to book a home rather than a hotel. And the model features are basically 3 different categories. Geography, which is very important for us because we don't have the same inventory in Los Angeles and Tokyo, for example. We don't have the same amount of homes to offer. The user history, clicks, like how many bookings he has from previous, how many NHA he booked in the past, and so on. And the context of the search query, like how many people are in the search query, how many adults, children, length of stay, and so on. And just to see from the Sharp value distribution that a lot of the features make sense. So for example, if people are looking for many adults, there is a higher chance, that's the red color here, there's a higher chance that you'll be interested in homes, okay? So if you book for 5 adults, good chance that you're booking for a home. If you clicked on many NHA properties during the session, there's a high chance that you will be booking an NHA, right? That makes sense. So, the features are behaving well. And another thing that was very encouraging to us is when we measure the conversion rate of the different intent scores. So on the x-axis, what you see here is the prediction of the model. And you have 4 bars here. So the grayish one is hotels, and the other 3 are different NHA types, single room, multi-room, and hotel-like. And first you see that all of the NHA ones are monotonically increasing. So higher intent means higher conversion rate. That's one good sign. Very large. What do you mean, high conversion rate? Yes, this is very sparse. I'll show the distribution of predictions. There are not many users there anyway. But so the conversion rate is increasing. That's great for all types of NHA properties. And the other thing is that hotels is not increasing. It's even slightly decreasing. So that means that the model is differentiating between hotel bookers and NHA bookers. It's not just identifying bookers, right? This is what we want. Okay, so how does so now we have this cool model. What can we do with them? So a lot of nice stuff. One of the things that we've tried initially is to create injections. So basically, the flow was as follows. In the beginning of the session, the intent model gave its prediction. We assigned it to one of 5 buckets according to quantiles, and each bucket got its own injection slot, and we would put NHA properties artificially. We would bump them according to their initial ordering of the ranking model, but we would just increase the rank according to the NHA, to the intent model prediction, okay? And if you would get, so what you see here is the injection slots that were initially hard-coded for each one of the 5 groups. So if you're in group 5, you have the highest intent, you will start seeing NHA properties on a very high rank. In the top 10, you will get like 3 NHA properties to begin with. So this is how we started using it. So we injected the properties. And this proved to be quite rigid. We started to think how to optimize it. So the first thing that we did is to separate according to device, because the number of properties you see in your laptop, on your big screen monitor, it's like, I don't know, 10 or 15. And what you see in your mobile, I don't know, top 5. So it doesn't make sense to have the same injection policy for both displays, right? So we started having injection configurations for both desktop and mobile and started to complicate and thinking how to optimize it. But then eventually we switched and we started giving a more continuous boost. So instead of just using fixed injection slots, what we did is to take the initial ranking score, which is distributed something like this, maybe look normal. And just add a bonus according to the intent. So this is what you see in the graph here is the prediction of the intent model. And this is the bonus, like how many points it got from the intent. And the blue line is this function, how much bonus we give. There's a reason why it's like linear and in different slopes. But what you see here is the distribution of users. So you see that very few users reach the high prediction rates. Right? So most of the users are very low intent and they should not see a lot of properties. What are the benefits of this approach? So, so first, there's more granularity. Instead of having just 5 groups, you get like a continuum of according to the prediction. It's much simpler to engineer, right? You don't have to keep a lot of configuration. It's just, it's a very simple thing to code. And it allows the controlling the ranking bonus with very few parameters. So if this is a function, you can define it by, I don't know, 3 or 4 different parameters that you can optimize and get a very significant impact on your business segment. And it independently of the ranking engine. And it relies more on the intent and the ranking engine than having like this fixed injection slots and configurations that maybe we tried a year ago, but we are not continuously validating if these are optimal. So this is why we switched to continuous boosting instead of injections. And now the question remains is how do you measure efficiency? Like how do you know what is the increased lift and how much it costs us? So the answer is similar to what Taboola showed. So basically we do a holdout experiment. Here the B side, the treatment is the holdout. These are users that don't get boosted at all. So they just see the hotel, the ranking engines results without any bias. And then we measure how much the different, you see that the hotels get more bookings and the NHA multi-room and single room get significantly less bookings because we remove the boosting. And we also know that the cost, according to the A/B test, we know how much money we are losing with this holdout experiment. So this is like our monitor. And this is very nice for senior leadership because now they can put a cost on what we do, like how much money we're willing to spend to grow the segment. And we are also know the benefit, like how much we are gaining by spending this money. And this could be like further applied to different engines or channels within the company, not just ranking. It could be in marketing or pricing or other internal units that we have could use the same mechanism. Okay, the second thing that we tried, we thought maybe the data is so sparse and so long tail, and the ranking model is so unoptimized for NHA properties that we could do better. Let's try to build NHA specific model on top of the ranking engine. And it would basically be sequential. So let the ranking engine give its list of properties. Some of them would be hotels, some of them would be NHA properties. and then let's re-rank them. Let's reshuffle only the NHA properties. We are not touching hotels. We don't know anything about it. We're trying to create a better ordering for NHA. And we will have a dedicated model with a dedicated data set and features that maybe would perform better. So we tried that. We built a light GBM model with lambda rank loss function, and we did the learning in pairs. And then we just applied it on the top K NHA properties, got a point-wise ranking score for each one of them, and just resorted them again, okay? And one interesting thing that we had to be aware of, almost went live with it, is that we added latency, right? This is also always important in recommendation systems. You could do something very nice offline, get very nice results, then you launch an online experiment and everything crashes because you added like 50 milliseconds to the loading page of and the user just bounced. So we had to work very hard to make the predictions parallel and not to add latency and so on, or little latency. This is a very important part of the process. But the result of this was not good. I mean, we spent a lot of money and we didn't boost NHA as we have hoped. And now we need to, this is like work in progress. Now we need to understand whether we had another bug or performance issue that we didn't understand. Maybe the model was not good enough, or we just need to ditch this approach. But this, as of this moment, it just didn't work for us. Yeah.
Model actually gives a different score, or just reshuffles like the ordering? So
given a property, it gives it a score, a point-wise prediction, and then we sort all the top K.
So it can like change spots with the hotel?
No, we just take the top K NHA properties. We create a list out of them. For each one of them, we create a prediction, and we sort them by the prediction, by the NHA prediction.
Yeah. I also have a question. Did you try the same model for this problem? The same model as the ranking?
Same architecture? What do you mean, the same model?
Same architecture. And same
data or different features?
Different data, same features, same architecture.
Okay, so just use the same architecture with NHA data, with same features as the original one. No, we haven't. Could be interesting. Another thought that we had is not to just override and reshuffle, maybe just do some kind of a linear weighting. So take the NHA ranking model score and the original ranking and try to combine them as an ensemble. Maybe that would work better. So this is like
motivation to promote this segment if you are sure that you will lose money.
Okay, so like in any, so basically in a sense, Agoda wants to be the Airbnb of Asia, right? And Airbnb is still not making money, I think, after 15 years. When you grow a segment, you have to pay in order to get market share. You need to, for example, if you want to convince, this is another thing something that we do in the project. For example, this is from the demand side, but we also work on the supply side. So try to identify these promising apartments, for example, in good locations in cities, and sending our sales representative to try and onboard them to work with us. So this is one thing, how we predict which one would sell well in our platform. But the second thing is, a very common thing is that these good apartments are onboarded. They don't get a booking from Agoda for 1 or 2 months, and they just leave. Because, why should they, have the headache of working with another channel? So sometimes we have the incentive of just giving them 1 or 2 bookings to see that we are legit, boost the ranking engine from our side, but also showing them that we could provide them with real business value. So there are a lot of business considerations going on.
Thank you.
Okay. So the next big thing that we're going to try, and maybe you would argue that this is the first thing that we should have tried, or the simplest thing. Why not just tweak the weights of the model and give NHA bookings, for example, more weight? Let's say that $1 C from NHA is now worth, I don't know, 50% more than hotels, and just let the ranking engine do its magic. Just bias the model in that direction. This is something that sounds very easy to do, but it's not quite easy because of two main things. First, we don't know how much we should bias it. It's hard for us to do it. And the second thing is, when we change the value of something in Agoda, we change it company-wide. We can't change it just for ranking. It would also take into effect in, I don't know, our marketing spend in Google. So now we will start biasing everything on traffic from Google, for example. So it's very hard to when you change this value, to contain it only for ranking. So this is like a technical thing that prevented us from trying it, but we will do it soon. And another thing that is interesting, and with the intent score that I've mentioned, we can combine it, for example, with marketing. So for example, if someone came to our website after he Googled apartments in Tel Aviv, and he just landed in the Agoda website, so his NHA intent should be high, right? Because its keyword in Google was very high. So we want to preserve this. So we want to integrate the intent as up as we can in the funnel, the user funnel. This is one thing that we are looking at. And another thing, the intent model is, and maybe I will summarize with that. So the adding a segment-specific personalization model is a very nice way to gain volume while maintaining efficiency. And it's a very flexible tool because it could help with the cold start problem. For example, I've mentioned giving these first bookings to new apartments. We want to show these new assets to people who have already have high intent, right? We don't want to show them to people who are looking for the Hiltons and Marriott of the world, who are not really interested in apartments. So it helps us tackle the cold start problem, and you can use it in a bunch of things. For example, you saw the filters on the search page. Why not show custom filters for high NHA intent users? For example, a filter, show me only homes if you are a high intent user. So it's a flexible thing that you can use in the entire session other than just the ranking feed. I hope this point is clear. Another lesson learned is that latency and user experience is very important outside of the offline optimization, and stable diffusion images are very cool. This is another one from Stable Diffusion. I just want to wrap up and open up for questions, but I want to thank the two data scientists that work on it. So Chaim was the first one, started a year ago, and now Omri is leading it. Now he's in Bangkok working very hard from our headquarters, as you can see. Both of them led this project, so I want to thank them. And I think that's it. So if you have any questions, I'll be happy to take them.
Yeah, I have a couple of questions regarding learning to rank problem. When you described re-ranker model, what if we try just some list-wise approach beside pairwise and point-wise that you greatly described? And another one question, it's what if we do it, how we could count some position bias, because for sure our model will be biased by some positions for higher positions.
Okay, I have a problem when people ask a few questions. I only remember the last. So look, the first one, why didn't we do list-wise optimization? So there were a lot of engineering aspects involved. One of them was we wanted to work with a tree-based model because we wanted faster development. And we understood quite early that latency is going to be an issue. We wanted to parallelize the queries, and that doing like a pointwise estimates were our way to having independent predictions that we can aggregate in parallel, just to make the prediction faster. It could be that, if we worked with an RNN or TensorFlow or something that would be more natural for batch prediction, it wouldn't be a problem. As for the second question, which now I don't remember, no, I will remember in a minute. That's what will drive me crazy. I don't remember, honestly. Okay, so another. But you need to speak to the microphone, otherwise people won't hear you.
Could we utilize some another features? For example, if I search something, for example, apartment in Tel Aviv or another in Jerusalem, for example, I do ranking. I probably go into this page. I saw it and I don't like it. I just cancel and start another one searching. Could you utilize whole history?
Yes.
User history.
This is what we call a session.
Yes.
So we have session-based users. For example, if you clicked on an apartment and went back, it's a feature of the intent model and it's updated. So your prediction would go high if you just continue to choose apartments to look at. So it would be adaptive in that sense. Yes.
I think I remember the second question.
Go for it.
I remember only keywords, something on position bias.
Oh yeah, right. Position bias. Yes, yes. So obviously, when you optimize ranks, there is a position bias. There's a lot of it's a subject for another meetup. But what we did in training the NHA ranking model, we took their position just on a binary, who was on top of one another and who was actually got booked. And if a property was beneath someone else and it got booked, it means that the user was not interested in the higher rank. So this is a strong signal for the model. So we made it a binary up or down, and which of the pair actually got booked. So this was how we came up with the training set. Yeah.
Just the question is not so related, but if you want to take it. My problem is that when you ask who Agoda is, and almost everyone didn't know about it. I mean, it looks like, okay, you're working on your rank, but your rev share, I don't know, maybe you have a rev share because you are on a Google search or something like it, but people do not remember you as a company of apartments and hotels. And I think that the most simple thing is that booking, what you are doing, Airbnb, hotels.com, things like it. But Agoda, what is Agoda?
The meaning of the name?
Yeah. It's not remembered. Also, if I will use it, maybe I use it once, but I will not remember it.
There's a Kahoot now for new employees.
Yeah.
And there is a true or false question. Is Agoda because of pagoda? Like because it's Thailand and so on. And I remember the answer is false. It's not because of it. Do you know, Vlad, why Agoda? No. So I will get back to you. I don't know. I think booking is a very strong name, but I don't know, kayak is for paddling in rivers. Why it's not like related to flights?
No, you don't want to be kayak.
No, I'm just you were talking about brands, right?
Site it has too much Google search, but nobody just going to look there. Almost no one.
Yes, but by the way, your perception is very Western. A lot of the market shares of Agoda are Asian, a lot of Chinese, Korean, Vietnam, Japan, and a nice English name won't mean a lot to them. So booking is focused in Europe and US a little bit. So Priceline is in the US, so it makes sense. Agoda grew in Singapore and Thailand and all of these places. So.
Thank you very much.
Anyone else? Yeah.
You mentioned the efficiency before. Are you taking into consideration the different parameters that may be vary from time to time? For example, the place where you choose the NHA in proportion to the hotel price or maybe the seasonality, because some of the times there are more demand or less demand.
So you're saying efficiency could be affected by external factors like seasonality?
Yeah, for sure.
Or COVID, for example.
Yeah.
Right? It was easier for us to promote homes in COVID, definitely. That's true. First, you can't compare, like when you compare different points of time, like it's hard to compare efficiency now to what we had 2 years ago, but it is very useful to compare what we have in July to what we have in April, in the sense that not a lot of the market trends are not that jumpy. Yeah, I mean there's a lot of noise in this metric, but the good thing is that it's very easy to come up with a price that you pay, opportunity price that you pay, and the lift. It's also, I didn't get into it, but it's not a clean A/B test, because the big guys that are in the holdout, they don't see boosting, but they still use the same ranking engine that is benefited from boosting. So for example, if you have a new apartment, it could be boosted on the A side, get its first booking, get promoted, and then the guys from the B side, from the holdout, could book it without any bias or artificial intervention. So they're using the same ranking engine who is constantly updated. So it's not a clean experiment. So it's even like a lower threshold of the effect of what we do, a lower bound, sorry. Yeah, it doesn't answer your question maybe very well, but we try to compare it in a shorter time frames.
We have a couple of questions from the online.
Only easy questions, please.
So I'll pick the easy ones. How do you handle the dependency between your other models or business decisions, like the injection policy, to the intent model results?
What was the beginning of the sentence? How do we handle
your other models / business decisions, like the injection policy, to the intent model results?
Okay, at the end of the line, we want to make money. The framework is like I've described. The KPI is we want to gain more LTC. So if we improve the intent model, or we change, not working with injections, but now boosting, if we change the boosting mechanism, it is all A/B tested. And we only take an experiment whether it improves our, our results. So we look at the efficiency, how much gain that we got for NHA. If the price is acceptable, then we take it. If not, we don't. So it's the framework is the same for every component that you try to optimize.
Another question, learning there. Did you use triplet loss or list-wise loss?
I think we use triplet loss, not 100% sure.
Okay.
One last general question.
You and Booking.com actually belong to the same group companies, and Booking.com have a great ML group, and you have nice groups. Do you somehow share the knowledge in this field?
Yes, we do. First, they have offices not very far away here in Begin. We are sister companies. It's the same stock in the market. We are influenced by the same trends. And we really try to work together. We share insights, experience, data, and models more and more over time. Also, there is like places we can directly compete with one another. So for example, if you see on Google, if you search for things, sometimes you see a Agoda ad and booking. So we try not to step on each other's toes too much and help on the data science part. We collaborate quite extensively. But there are a lot of commonalities, but there are things that we are doing that they don't, and vice versa. Yeah.
And so the question that I have is, do you have like also a difficulty of actually measuring the MHA for like home properties?
Yes, measurement is much noisier because you're measuring, let's say, on 10% of the data, right? So the convergence of experiments is lower and so on. So measurement is noisier. Sometimes we use also secondary metrics. It's another discussion topic, not just bookings, but proxy metrics. So for example, how many people reach the booking forms of NHAs. So it's like a micro conversion, or there are different names for these things. So it's not exactly what the business KPI is, but you get bigger numbers and you hope that it is correlated. So sometimes we use this. Yes. Still 21 brave people survived.
A question about offline evaluation of different methods, models, etc. So it's obvious that in this type of problems, it's much easier to go to online A/B testing. But have you tried to take advantage of offline evaluation and have some decision in this regime before going to online? And you know.
Yeah. So we have our online metrics that we optimize for each of the models I've presented. Yeah, so for example, if we try to update the intent model, we try to first do an offline check to see that, I don't know, simple metrics like, okay, you see how improving and a few others. But eventually the offline metrics are a way for us to do faster iterations and take the best candidates, and everything goes through an online experiment eventually. Yeah, but we do a lot of offline optimization. Sure. Thanks for your patience.
Thank you so much, Yair. It was really, really interesting. And I just want to invite the third and final speaker for today, Tamara from Toloka. She's going to talk about how the push recommendation system using data labeling. And a small update, after the session, we're not going to have discussion panel, but you can mingle, you can drink and ask the speakers directly any questions you have. So this will be the final talk, and then we can party. So tomorrow.
Hi, everyone. I'm Tamara from Toloka. I'm currently working on solutions that help to improve our clients' search systems and recommender systems. My talk will be mostly focused on the systems that are used by e-com magazines, shops, but this information can be scaled to any area where you use recommendations. So I will start with brief introduction on you all have heard some of your friends telling that your phone is listening to you because it's like showing you on the search something that you have just thought about or just told your friend. And I've got lots of my older relatives, and I'm sure somebody is spying for them. But the thing is, and you all know about this, that some websites have such powerful recommendation systems that it seems like somebody is reading your mind, but it's just like several neural networks, and you're so predictable. But there are companies that come to us, they have problem with something isn't working, and they are not in this category of companies that I'm telling you about. So we have collected the list of problems that they face because of bad recommendation systems. And it's lots of relevant stuff on search engine page and in the recommendation section. And you're it's somebody is looking for a Galaxy Note, and instead of getting some nail polish because it's number 10, it's long time to find search elements, high churn rate of users. And these are problems that relate to most of e-coms, but not every company knows that they can be solved via offline labeling. And I'll tell you how. Oh, sorry, it's the wrong order. So what is offline labeling? You use the power of crowd to make a decision to determine whether search results or maybe recommendations are useful to the user who will see them. So for example, in this page, you see this is like some search on the internet, and you ask our performers to classify which of the products in the output are relevant or irrelevant, or which category. And after classification, you know everything about your output system, because online signals, it's something implicit. So you know that user have clicked on some web page on some item and looked through it, but you never know what was his intention. Maybe he saw a beautiful picture, maybe he made it by random, maybe he just wanted to check something, and it's an implicit signal. You never know whether this is caused by something that interests you. And also, you all know that it's not more common for e-coms, but for some such systems, it's a big problem that if you use only click-through rate, your model can get really prone to clickbait. So there are search systems, they never use only click-through rate, because otherwise you will get in your results page some articles on Madonna's looking hot, or maybe how to cure cancer with soda. It's real cases. So this is the problem that you can face if you use only online signals, but offline labeling is just a useful tool to correct the things that is going a little bit wrong in your system. And also, I have forgotten to mention that offline labeling helps you to, sorry, I think it's, yeah. Offline labeling helps you to first achieve scalability, because every company has faced the problem of cool start when you have a new user or maybe new product and you don't know what weights to assign to it or how to promote it. And if you ask directly with offline labeling, you will already have this information. And also it's a good way to enrich your ML model, because now we all know that ML and DL models are some giants. Feeding the much data you feed to it, the better it will get. So current models have already seen the ordinary types of data that they have been fed up to, but adding offline data can help you just get out of this glass floor and go to next level of quality. So it's a small example of how can your offline labeling project look like, the simplest one. So you have iPhone 13 and you show to performer on some labeling platform two items. It's this smartphone and the case, and you ask the user, is it a correct recommendation or incorrect recommendation? And because such verdicts are really cheap and fast, you can collect a vast amount of data, and you will be sure that the items that your recommendation system is showing are really valid. Another type of this product could be instead of this case, you got another case and you ask which one is better. It's about what Yair was talking, pairwise comparison and pairwise ranking. Sorry. So And it helps to increase the accuracy and recall of like ranking, of recommendation. And I wanted to tell you about how to use offline labeling in recommendation systems based on what are the main fields in recommendation systems right now. So you all must know about them, but let me just briefly introduce them. So the first one is collaborative filtering systems. It's the one when you look through your users of the website, you check what they were looking through, what they were choosing, what they searched, what they have bought. And after this, you like make this metrics factorization and find the similar users that have similar interests and can buy similar items. Another type of filtering systems is demographic. You like try to extract recommendations for different type of demographics stratas, like different ages, different genders, education background, and etc. The third one is content-based. It's information filtering methods when you look not at the customers who have already bought this item, but on the items itself. So you try to produce as much product features so that you can compare the items in your catalog and find which are mostly close to each other. And the fourth one is knowledge-based filtering methods. And this is like the job that all companies are doing all the time. It's like about doing research on your customer needs, on what is trending right now, what people want, what people will want. And it's also shouldn't be like underestimated, because it's a simple tool, but it helps you just to get into the apple of the people's needs. And the fifth category is hybrid filtering. So you can actually take any of these and combine them. This will have like a more difficult neural network structure, because for some of them you use autoencoders, for some of them you use metrics factorization, for some of them like difficult ranking system, but like playing with factorization and autoencoders helps you to get these data into one batch of vast amount of data that you can use to predict some recommendations. And this is what gives you this effect of somebody is listening to us. It's like a little bit noisy because you have data of different types, of different categories, but if you settle the weights perfectly, it will look very good. So now I'll tell you how offline labeling helps to get this data. First of them is content-based filtering systems. So for them, you can just, you've got lots of items in your catalog, but you just kind of, there are some features you can extract, but some features that are hard to extract from the catalog by ordinary NLP models. And sometimes you need like these hand-picked answers to first train these models, and second to like get more vast information. For example, there is a big problem in e-commerce that is called ASIN to ASIN, because like some companies have different catalogs for different regions, and they have a problem to match the items from catalogs of different regions. So it sounds like it's your own catalog, it's items that you sell inside your company, but some information is really hard to retrieve. And to do this, you maybe can use some models, but to use models, you need to first train them. And here is where labeling helps you. And also you can just like ask any other questions about like items that you are showing to your customers. So the next one is knowledge-based filtering systems. It's about like trends or some needs of customers. One of our great example is that we like made a project on fun toys for recommendations. So there are recommendations on the web pages that are connected to some items, and recommendations on the main page that are just some stuff that you would recommend your users to buy. And like you can just ask users whether the product that you show to them is an unusual product or an ordinary product, or maybe is this skirt trendy or not, or maybe like it's already cold, would you prefer this blouse or this blouse? So lots of different questions that you can ask your performers. And for collaborative filtering systems, crowdsourcing is kind of not enough developed, but I see that there is some room for improvement, because you actually can like show to labelers some search queries of different users and ask him whether these users belong to some cluster or not, or maybe what the users that were searching this thing. So for example, somebody was looking for beer, for diapers, for like, I don't know, some books for children, whether he's like, you can ask the performer whether he is a single father or maybe like somebody else. It's like you actually can impose any question you have. So the problem here is only to make the data anonymous. And for demographic filtering systems, we have lots of, and other crowdsourcing platforms have lots of filters that you can apply. So you will get the precise customer auditory that you will use to sell the items. So you just take the same slice of audience and ask them whether they're interested in these items or not. And I would also like to show you some other ideas of how your projects on crowdsourcing look like for relevance. So for example, somebody is looking for music system and we show him some items and ask him whether they are relevant or not, or maybe like for coffee bean grinder, this item, is it like substitute, complement, relevant, or other? Or maybe if, try to define for which category some search query could belong. For example, what was person intending to get when he was looking for some like kitchen table. And after this, when you like train your model to extract such data, you can also build your recommendation on them. So for example, if you know that your user is looking for some hairspray for oily hair, you know that the keyword here is oily, and everything that you will show him later will recommend him something with this keyword. Again, this is complementary goods. It's either pairwise, showing that either this item is better for this one, or maybe like ranking of how relevant this item is or not. And for category recommendation, you know that user is looking for like some dress. It's a really non-trivial problem. and you like make a recommendation inside this category, and you recommend the needed categories to the user. And like another example here is there is a problem in such systems where when somebody is looking for Jaguar, is he looking for a car or for an animal? So you like need to first evaluate the category, then to rank the categories, and define which one is more suitable now. But there are some blending models now that help you to like enrich the search output with both categories. But you can also label data to make this model. And fun goods to recommend is like something I was showing you before. And like I'll skip this slide. And crowdsourcing helps you to get answers for all these questions. And actually what I wanted to show you is that you can use crowdsourcing for any possible question that you have. So you like know you have trouble with something, you use crowdsourcing, you build some simple model or download something from GitHub, relabel like data with crowdsourcing, and using transfer learning, adapt this model to your problem, and you implement it to backend, and you have like a simple solution to what was torturing you and decreasing your sales. But another thing that crowdsourcing can be used for is evaluation process. So you have created some model, you are showing something to people, and you actually need to get sure that you are showing something that is valid. And so this problem, it also shows how crowdsourcing works. You just take output of your ML model, you sample the required amount of data that you want to examine, you send them to crowdsourcing, you ask people whether like the recommender system showed that for this region, for this gender, and for this age, these clothing categories could be useful. So you ask users whether they think that the model was right or not. You aggregate answers, and you get the verdict. And you calculate metrics that is like evaluating your model. And after this, you can make a verdict whether your model is working good or not, whether you can like have some spaces where you can boost its work. And you can do it anytime you want. And I also wanted to show you this slide. It's Yair mentioned something like this at the end of his presentation. So about introducing some models to your backend. It's another use of crowdsourcing here. I decided to show this slide because we like talked about it earlier. So if you have several recommendation models, you need to decide which of them is predicting better. So conducting online experiments can be really expensive, especially in like e-commerce, when you really lose money when you show something irrelevant. That's why you can first create an offline evaluation and check for output of each model, how good it is working, and like score your models, choose the best of them, and after this send them to online. And then you can like out of 10, for example, different models with different hyperparameters, you can choose very fast and very cheaply. You can choose, for example, 2 candidates that go later to online evaluation. And after this, of course, there is A/B testing and all this difficult stuff. So I think that's everything I wanted to tell to you. Again, I would like to conclude that crowdsourcing is like a tool that you can use for any problem on this planet. And these are like slight list of problems that we tackle daily, but actually when clients come to us, they often have some really different problems and really weird ones, but we know that with crowdsourcing we can solve most of them. And it's like not the thing that will replace AI or vice versa. It's like the thing on which shoulders AI and ML is built and can be improved and improved later. So that's all. Thank you. Like if you don't feel that I'm according.
I have a question.
Yeah.
A microphone or
I guess yes. Is it turned on?
Thanks. You've meant it's not a new problem, but a lot of these tagging kind of subjective, right? Especially is it is it a surprising or a unique toy or trending toy, or it is also affected a lot by your cultural background, like I don't know, you had the candles of
And you want like these explicit thorough signal that will answer specific.
A really big instruction where you would include all the points that like are important for you, and you will train people to behave according to this instruction. They will go through examination. So you will just like have robots who will answer according to your orders. So it's like there are two approaches. You
mean specialized labelers, right? Specialized annotators.
Yes.
Okay.
Yes. But with crowdsourcing tools, you actually like most annotating tools are limited to the number of annotators that are available. And if you use crowdsourcing, that is like projects that are settled in the right way, you can scale these really difficult projects with strict requirements to any amount of users who will like, not any, but a really big amount of users who will go through these tasks.
Demographic features, I guess if you're asking about toys or I don't know, something for teenagers, I wouldn't know anything to label them correctly. I'm not the user, I'm not the target audience for these kind of products.
Yeah, it's actually one of the problems we are facing right now, because while researching the market, I see the need in such tools, and we are like developing a tool that will, based on the previous answers of this Toloka, what are his interests, what he's best specialized in, what are the spheres that he is an expert, and using like this smart filtering section, it's ideal to show like choice for these users and like guitars for users we know that are good in music, or maybe computer games for somebody who's interested.
Any other questions? Maybe tomorrow. I think we're gonna wrap it up. So first, I want to thank all of you who came and stayed along. Thank you so much. You can communicate with each other. You have, I think, like 20 minutes. You can go and grab a drink, and the speakers will be here for another 15, 20 minutes also to answer your questions personally. And also want to thank people who joined online. We're going to end this broadcast. So thank you so much, and join our next events.